things that I've kind of like realized being CocoaHeads and MS coders is there are different approaches to going about doing core data, and it kind of became pretty obvious to me that if you're trying to explain one or the other, it's easy to get them confused. So I needed to unconfuse them. So that's the basis of these slides. I've altered them to not do some of the more specific OCPNer things. And I wanted to go ahead and share this with you guys so you can make your own decisions. So here are some examples of, like, okay, so you decided that you want to do some core data. You want some persistence. Here's some examples of potential goals that you might want to have for your app, right? The first one, which is really prevalent, is just get it done as fast as possible. We'll worry about other stuff later. Don't worry. Speed. The other one is supporting offline mode. I'll be talking quite a bit about that. That is really its own thing. There's a lot of effort to actually support offline mode. Some choices, and I'm going to mention GraphQL. I think it was like a year and a half ago we had someone do a presentation on GraphQL. You could choose between using GraphQL or standard APIs. These things apply to either. It doesn't really matter. Just as a side note, we were looking at Apollo, which is basically an SDK to do that. We figured out a way to do it without using Apollo, and there are thousands of lines of code. If you're interested in that, I can talk to you about that offline later, or maybe I could even talk about how we do that. But that actually wound up being a good thing for us, and we're going to use that. Speedy user performance. This is not fake, and it's not. It's something that is very, very real, and I'll explain more about that later. Keep personal data local. I mean, maybe you want to do things like some local pictures, local data. You're not necessarily going to share with the whole world, but you just want to keep some local things. Another one is supporting iCloud. That is its own thing if you want to do like multiple device support. So this is just some examples. You may have your own. You may have worked on some projects that may have included some of these. It's not meant to be inclusive. So there's a couple of approaches that you can do to data, right? So the most typical one we deal with are server requests as opposed to core data. So this is non-persistence basically. So this is typical examples of the difference between the two, right? So server request, you authenticate and then you fire off a ton of APIs, right? It's not unusual to, I've logged in or I've checked my authentication token. Now I'm going to do 15 APIs to get all the data I need to do the initial screens. That is not unusual. Contrast that with core data persistence. And so yeah, on startup, you do want to check your authentication. And yeah, at that point, once you do that, you actually want to do a background database sync. Right? So in other words, if your authentication's okay, you're in. There is no need to wait for a bunch of requests to actually get you to start looking at UI or populated UI. So we were talking about speed advantage. It's one of the speed advantages. It's a whole lot faster to make a local request with core data and populate your screens than it is to wait for your 15 API calls to happen using spinners. So speaking of spinners, that's number 2 on the left here of server requests. Empty views and spinners until your data arrives. This may only be a second, but I don't know. If things are really rough, it may be a lot longer than a second. It kind of depends. And it's not unusual to have apps where, yeah, you're kind of logging in, and then you're seeing a spinner for one thing, and then you have a tab, and then you got a spinner for another thing. Kind of depends on how you build your app. But that is a typical behavior that the user sees whenever you're using strictly server requests and no persistence. And as I talked about with core data, the philosophy is you instantly show data. The moment you go in, you see data. There are no spinners. Ideally, that's what you want the experience to be. And then once you get your results from your server request, once you get back your JSON results, whatever, then you start filtering and sorting, usually based upon if you have large amounts of data in order to get to the specific things that you're looking for. This may or may not be true, by the way. So it kind of depends on your APIs and what data you're grabbing. Contrast that with core data, which is, you're doing fetch requests, and the differences that you're making are based upon predicates, and your sorting is off sort descriptors. So it's all happening at one time, because you're gathering your data from a different spot. So those are two very different approaches to how you want to do data. Continuing on, we post data requests to the server, and it comes back and we show results. Whereas with core data, you actually post data requests really you save data instead of posting data. So let's say that you decided to do an insert on something, right? So typically, if you're in server request mode, the first thing you do is do a post API right then and there. And then you show the immediate results then and there. If you have an error, you show an alert. If everything's okay, you move on and do your thing. With core data, one of the approaches you can do is to say, once you've said, hey, I want to do this insert, you just insert it into core data. Okay? And you can do the post whenever you feel like it later. It's all about saying, look, everything that's interacting with the UI, the interactions, the tasks that a user is doing in the app, the primary thing you do is save the data, the core data. And then you figure out the API connections later. So there is no waiting to see if it succeeded. It's, no, you succeed by saving it, and then you try to do the connections later. Complete all steps for server requests. So it's not unusual that whenever you're trying to do tasks that you have to go through a series of tasks to actually do something. A good example for OC Tanner, like if we want to appreciate someone, well, you got to search on someone, and then you've got to figure out, what's the program, and how do I want to appreciate them? Is this a nomination? Is it just a little thank you card? Are there points? There's like all these steps that they have to go through to complete one task. And because those things aren't really necessarily saved a lot, if there's a failure anywhere along the way, it's not unreasonable to say, shoot, it didn't work. And, it's all gone, and you close the app and everything's gone. That can happen, completing all the steps. If you have core data, what's interesting is you can easily create drafts and persist them. And you can even take your drafts and save them across iCloud as well. Like let's say that you start to do some 10-step process of something. You start it on your phone, but then you want to finish it on Mac or iPad or whatever. You can actually complete a draft. This is pretty standard stuff for most mail programs. And searching. So server requests are, okay, you start typing in a bunch of letters, and then depending upon the delay, have you finished typing or not typing, then we go out and ask the server to give us a result set based on however many letters you typed in, and then you display that. And then if you type some more, you go back with another API, you do it again. So you continue with the APIs back and forth, and that's how you get your results. That's how a server request non-persistent way goes. But if you're using core data, you can say, let's say that you've got a list of all of the names of the employees, or just the team that you're always going to interact with. If that's persisted in core data, there's no need to do an API call, because you can get a list of anybody. You can still do the search and type in some letters, but your results are going to be super instant, because it's just fetches to your core data. So huge difference in speed. Okay, so the design itself. So typically, whenever we have the requests in the mobile world for us, it's usually we have the leftovers from whatever the web page guys ended up having. It's like, well, here are the APIs that we use for web. You should just consume those. And that's very typical. That's actually the norm of most projects. So you wind up having a lot of API calls. I know that our current app, we do 15 right away to try to get different things that we're looking for. Some of those things are related to just the person who's logged in. That's typically what it is. We're just making API calls all the time. Okay, so if instead you're using core data as an offline repository, it's a different story. So what do I mean by offline repository? One approach is, okay, so you're going to persist requests. Another approach says, we're going to persist in order to create an offline repository. It means you're asking for different things. So for an offline repository, you want to get big segments of data, and then you figure out the relationships locally, right? So let's take, for instance, employees or people on your team, right? So you could make a thing that says, give me all the employee names, just the pertinent data that I'm going to need to do my stuff. You don't need everything, right? But pull all of that stuff that you need. As opposed to, like, you could have one API say, well, who am I? And make another API say, well, find my team, what are the relationships on this? It may take 2, 3, 4, depending on the APIs, API calls to figure out who's on your team. Whereas instead, if you're you're saying, hey, just, open up the hose. Give me everything. I'm going to persist all of this. I'll do all of my own relationships based on the structure that I see. Now all of a sudden, you've already got everything, and it's one API call. Is it a bigger API call? Yeah, you bet. But it's sheer numbers, right? So typically, whenever you're doing server requests, you've got very small sets of data. It's like, oh, the JSON's typically not very big. Whereas, like, if you're asking for all the users in an organization, like, depending on how crazy that gets, that could get really, really big. But I've had, like, tests where we're doing, like, 15,000, employees and downloading them and processing them as part of large data. Yeah, sure, but if it's all in the background, who cares, right? Doesn't matter how much it does. So it's like smaller chunks of data and doing smaller inserts versus taking larger pieces of data and saying, I've got all the stuff that I need. All right, so now we talk about data structure, right? Who is driving your data structure? Typically, the way it normally happens, and I see this a whole lot, is they decide what the design is. It's like, oh, well, I'm going to make the core data structure match what my view designs are, because that's what I got to deliver. That's part of that. I need it now. Just get it done, right? Here's the designs. Get the thing to get it done. That's fine. This is the norm. But if you think about, MVC, right? You want your data to be separate from your view. So if you design your database, right, your local database, based upon what your view requirements are, I don't know, you could say that's busting MVC psychologically, maybe even literally. But that is typically what is requested of us as developers, right? The alternative to that is, no, the structure is driven by the server design. It's not my view design. It's like, what's on the back end? What's available on the back end? If I'm going for people, if there's a people entity, why doesn't my people entity mirror and match the people entity that's on the server database? Those are two distinctly different things. They may not seem like it, but they definitely are. So here's one of the other things that's really common that happens, that if you're being driven by your view designs, it's very, very fast to start denormalizing data for simplicity, right? It's like, okay, so I've got a person and there's like an attribute of, does this person have a parking space or not, right? Or who is their manager? It's very, very easy to say, just throw in the manager's name. And then you can, like in the database, you'd see these records with the same manager's name over and over and over again. If there are like 12 people, okay, the manager's name has been repeated data 12 times. This talk is not about normalization, but that's obviously busting normalization. But the reason why the normalization is okay is because, well, we're just trying to make this simple, right? I just want to simply have this data that I need to run the view. Now, that's fine for running the view. The offline repository approach says, I'm going to normalize my data and I'm going to index it for speed and search. And so this is a fundamental difference. Just trying to get something up there and persisting request results versus saying, I'm going to normalize all of my database things so that everything I do is really, really fast. And if search is a part of my app, right? I'm talking about app goals. Is search a part of your app? If the answer is no, then maybe server request is totally okay. But if you want to have like offline and you want to have really fast search, no, you should definitely go for the normalized data. Because remember, when we're asking for requests, if the back end isn't normalized and indexed, we wait longer to get our results. The same thing is true of our local core data. And searching. This is the question you got to ask yourself: is how big and how important is searching to my app? Yes or no? The answer is no. Then okay, partial local data if you persistent stuff, and maybe you have to go to the server to get other things. That's a choice. That's a decision that you can make, and that's okay. But if you decide to go for the offline repository approach, you can just search anything you want to anywhere with any combination. And that includes upon relationships. Usually whenever you're doing this searching of partial local data, usually don't have a lot of relationships, if any. So you have to make another API call typically to figure out the details of the relationship of the thing that you're searching on. Again, you're potentially making more API calls. Whereas if you have an offline repository, you're not making any of those API calls. So let's talk about advantages and disadvantages for each one. So APIs, whenever you're, typically, this is really typical. APIs will just grow like crazy. Let's say that you're doing Codable and you've got your structures. Every time someone's going to add a feature, yeah, usually there's one to who knows how many APIs that you need to add on. So next thing you know, you got more and more APIs, more and more decodable structures that you have to deal with based upon the result set of those APIs, right? Even though a lot of these APIs might be hitting the exact same entity, right? You're just getting subsets of something from one API call, and then maybe other sets of things from another API call. So it's really easy for these things to just grow like crazy, right? Whereas if you're going the offline repository route, you've got fewer APIs, probably exponentially. It's probably going to be a third, maybe way less. That is not unusual because you're not just going for certain sets, you're trying to basically create a mirror of a local repository, which means you're getting the bigger data, fewer APIs. The advantage of having smaller data, though, is it's less complicated. It's a lot easier to understand. It's like, okay, here's the API, here's what the result is. I don't have to think about anything in the future or anything else that's going on. I'm just going to do my feature and do my thing, and it has a small footprint. That's a valid point. That may be what's right for your app. If you are actually, whenever you're dealing with larger data, which is the offline repository, yeah, it's definitely more complicated. And yeah, it's going to be a bigger footprint. It's going to, just because the sheer number of records is probably going to be much bigger. But, you know, that's part of the deal of having more power and having especially more search power. That's the trade-off is, yes, it is more complicated. There is more stuff to do. Data binding, especially in our new Swift UI world, data binding to a view is easy, but it's also limited. So the bindings, I mean, depending upon how complicated your view is, and like, does it have sub-relationships and a bunch of other things involved? Yeah, that can actually get complicated, but in general, you're not showing a lot of stuff, right? With an offline repository, binding can be more complicated, but you become essentially view design agnostic. You don't care what the designer comes up with and changes and says, oh, I want to add this other little thing. If you're doing the offline repository large amount, it's pretty easy to add that, and in fact, you may already have that data, so you don't want to have to change any code except what your view binding is. That's it. So there have been a lot of times that I've had excruciatingly wild design changes that because of the approach with the offline repository, I didn't have to change any APIs. All I had to change was the view, because I already had the data that I needed. That is not unusual. So in this respect, the requests are pretty short term. Whereas doing it with the offline repository, your potential to handle any changes long term are pretty good. Data integrity. This is one of the things that will make your backend server database people nuts, right? Is they are always worried about data integrity. And that's because there are so many authors of updating the database that if all of those things aren't in line, it's easy to get the wrong data into certain fields. And they don't know about it until later. It happens. So really, the data integrity that you have locally really depends on the last API that updated it. If you have multiple APIs that are updating a record that you're persisting locally, who's really in charge of that? It's whichever API, whichever custom API that was. That could be 5 different APIs that are controlling one record inside an entity in your core data, potentially, easily. Whereas if you approach it like an offline repository, no, your data integrity is saying, I'm mirroring what's on the back end, right? So it's less likely that I'm going to have something different that shows up. Sometimes on these APIs you can have like string of values. One of the things that's really typical a lot is, okay, so I got a number back, like an ID. Is the ID a string or is it an integer? You know, I mean, that happens all the time. You can have half of your APIs given to you one way and another half given to you another way. Whereas if you're doing this It's like, no, well, what's the back-end database doing? I do my one API, and then that's it. It's just established. Searching. I already did talk about this. So what data you get is pretty limited. Yeah, I think this is copy and paste stuff. So I realize I've said this before. But the searching, if you have a full database, is a lot fuller and faster. You can search on just people if you want, but think about, does your app have the potential to have multiple entities? So let's say that you had something to do with, your coworker George, and maybe, okay, so there's George's data that you could bring up, but maybe in those search results, you have every interaction that you ever had with George. It's like, oh, okay, well, these are all the messages that we had, and here are the projects that we worked on together. There may be a complex number of different pieces of content related to that same person. If you're offline, you're going to have to make an API call for every one of those diverse potential pieces of data. Whereas if you've got everything on an online repository, they're pretty instantly at your fingertips, because you can make 4 requests, pull everything up as long as it's indexed to this person, and get a lot of results really, really fast. And here's one of the keys. If you're offline, you got nothing, except what you've managed to persist. But if you've got fully offline capable data, it's really easy for you to search all of that stuff. Trying to do the request version of that in your core data, it's a lot more complicated, it's harder, whereas it's pretty straightforward if you've got all of the data. Just say, yeah, run it against all the entities. That's a whole lot better than trying to figure out, oh, well, which entity result design thingy might this be in? It gets complicated. Offline strategy. Maybe you want to go offline, maybe you don't want to go offline. If you want to say, hey, everything's got to work online, that's a perfectly viable choice. Well, let's say that you want to go offline. Let's say that you want to do stuff like Wi-Fi. Let's say that someone's using an app in a workplace where the Wi-Fi and the cellular is really bad, but you still are trying to do a job. That is really challenging, right? So, offline strategy, what can you do? Obviously, the first thing you want to do is assume authentication, right? Okay, maybe you've got an access token, maybe it's expired. Why should you care? At once upon a time, you had a valid token, so whenever you bring up the app, just assume that everything is okay. That is certainly a viable strategy. And you can try refresh tokens, if you have those, or updating your tokens in the background. If something really goes wrong, fine, lock them out whenever you get that answer. But at least this way you can assume everything's okay, and I'm going to update it, which means you're not creating friction from the user trying to do what they're trying to do. Because vast majority of the time, they're a legitimate user. So let them move on with their life. Figure out the authentication stuff in the background later. The other thing is, the UI always assumes offline mode, no spinners. So whenever you access your UI, you're not waiting for any API results to happen. And you just assume, the design of it is you assume you're offline on everything that you do. That's making new inserts, reading things that go into views. You trust the data that you got last, that was good, until you do your syncing. We'll talk about when to sync is actually really important. It matters a lot to your database. But as far as the design of your UI, you should basically consider yourself isolated from APIs and network calls. It's like my data, my source of data is always going to be my core data. So I'm always guaranteed to show something, for sure. And there is no delay. That's part of the speed advantage, is that users don't have to wait for things to happen. They happen instantly. And funny thing that no one's ever yelled at me because anything was too fast. Assume offline for all actions, persist first as unfulfilled. So this is part of that strategy. So let's say that I'm inserting a new task. The flow, the process of that is that you save a new record into core data, and then you basically give it a flag that says, hey, this hasn't been synced, hasn't been fulfilled yet. But that's what you do first. You fix your data first, and then you figure out the communications in the background later. But as far as the UIs are concerned, you can say, oh yeah, I've got it. Maybe it's not fulfilled yet. Maybe you show the status in some way visually that it hasn't been updated to the server. For some people, initially, those of us especially technically would say, well, wait a minute, that's not really there. It's not really true. It's not done. For people who are not that technical, they really don't care. They don't care if it happens this instant or it happens 5 seconds from now. It doesn't really make any difference to them. So that is the approach to it, is that, no, you're always interacting with core data instead of APIs. So unfulfilled records, how do you do this? There are a couple of different ways that I've done it in the past. So this is an example of how to do it. A sync flag. So just a Boolean. Is this synced or unsynced? Right? And then you can know if in the background, oh, fetch all of the unsynced records of this thing. And then I can do them as a batch later and post whatever I need to do. Very easy to handle a Boolean flag. That's it. Status property. You can control this as like an enum for however many statuses you have. This is typical if you're going to do like a delete. Let's say you're going to have a record, you're going to delete it. And then you're going to update the server and say, hey, I need you to delete this thing. Well, that would be a status, right? It's like I'm unsynced and I've set the status for this to be deleted. So then you do your delete batch of all of those things that you have that are going to be deleted on the server. So that's how you can control those things. A third thing that you can use to help make offline mode work is temporary ID values. So typically, whenever you get IDs, they're an integer of some sort. So how do you do temporary ID values? You can leave them blank if you want, but that's kind of hard to figure out how to go back to. I've used negative ID values. In other words, you find out what the largest negative value is, and then you subtract 1, and now you have your new temporary ID. And depending upon the APIs that you're dealing with on the back end, whenever you ask to, let's say that you want to insert something, fine. The result set that you should ask to get back from your server, from your API authors, is whenever you come back with a success, also come back with the ID number that corresponds to that thing I asked you to add. And then you can just take that result and say, oh, yeah, I'm going to update my ID. Get rid of the negative ID, you already know what it is. Plus, if you're doing batches of things, like batch inserts, which, by the way, batch inserts in core data is new in iOS 13. So if you're 11, 12, sorry, you can't do batch inserts. This way you can handle your IDs and figure out what they are. Now let's say that you've got a batch of 10, and 9 of them work and 1 doesn't. Fine, you can retry the other one later. If things are catastrophic, you can figure out what to do after that. But that is one potential way that you can handle an offline strategy of things that you can do. Questions so far? Okay, so let's talk about more offline strategies. Like, oh man, Cole, there's more? Yeah, unfortunately, yeah. So the approach is to say that the UI is not involved in networking, right? Which is very atypical of what we're asked to do most of the time in our apps, right? So it's like, well, what's the exception to that? You know, some on-demand things, like if there's like a large image or something that you're trying to get, maybe you don't want to persist thousands of large images. It's like, oh, okay, you know, I want to look at this thing, and then you could just do like, you know, you would normally do, which is, oh, yeah, I'm about to do this view, come back with the image so I can go ahead and show that. And then you can decide whether or not you want to store it locally or not because they've accessed it. A lot of times that's a good idea, maybe it's not. The other thing is, determine timing for background fulfillment with the server. When to do the updates, right? So one of the things I talked about was, in the beginning, after you come online, you can decide, oh, okay, I'm ready to do all of my updates. I'll do them in the background. User is seeing everything that's in core data. You can determine when you want this to be. One of the things that I really like is the potential that, let's say that we're going to update a bunch of tasks that come to us. We can set ourselves up for background tasks with iOS, and it's using heuristics to know, like, let's say that your user at 9 a.m. every day, every weekday, opens up your app and always looks at their new tasks or notifications or whatever. You can actually sign up for that as a background task. And Apple will then determine, oh, you know what, it's 10 minutes before this person normally goes out and opens up your app. You can actually open up a background thread that will do the API call. You can process all of that stuff in the background so that 10 minutes later, whenever the person decides to open up the app, they've already got all the data. It's already there. You don't really care how big it is. Maybe everything that you had that was offline is already synced. So by the time they open up the app, you're already up to date. There's nothing to change. So, you know, maybe you want to make it every hour. Maybe you want to do it at night. There's also a thing that you can choose to say, let's say your phone is on the charger at night on Wi-Fi. If you decide to do an update then, there's a part in iOS where you can actually look at apps and see like how much data they're using and how much energy they're using. In this year's WWDC videos, they were saying that if you sign up to do it in the background, it actually won't count against your app if you're doing it on the charger Wi-Fi at night. So that's good to know. Another thing you want to determine is assets. How do you deal with assets? How do you deal with PII, personal information? That depends on what your business thinks. If you're going to typically download visual assets of something over and over and over again, yeah, maybe you save it locally. Maybe you don't. It's kind of up to you. You have to decide that. Another is determine if you want to use persistent history tracking or query generations for rollbacks. Okay, boy, that's a little intense. So what this means is, let's say that you've gone partially through a bunch of steps and you've persisted things and something goes wrong through half the steps. Now, like, maybe half of your data is wrong. What do you do about it, right? Well, you kind of want to roll it back and say, oh, this whole thing was a big transaction. Talk about databases and transactional things. You know, what happens if you're talking to the server and like half of the things are awful? It's a whole lot better to deal with rolling back things locally and then updating them. That's catastrophic kind of stuff. But typically, if you're dealing with requests and you're doing a bunch of steps with a whole bunch of APIs, you've really got no way to roll back. You know, you're kind of stuck. You're kind of in a position where you have to sort of delete and start over and do a new API call and do that. That's pretty typical. But fortunately, that doesn't happen a lot. All right, so final slide, I think. All right, so I haven't shown you a lot of pictures, just a few icons. So let's talk about some pictures. All right, what does this look like? Well, this is kind of what it would look like if you want to support offline data flow. This is just one sample. It doesn't have to be this way. But this is the way that you can do it. Our UI is strictly dealing with our middle layer. And I'm using SwiftUI purposely because why not be trendy? So that's our bindings, our state, whatever you decide that you want to use to connect to your core data. So with core data, the back and forth is, yeah, you're reading things, and everything that you're updating, you're saving things to core data. You're not directly dealing with networking at all. Assets, right? It's like reference by ID. What does that connection mean? So let's say that we've got a widget, and we've downloaded a very large widget image or video or whatever. Let's say that this widget has an ID of 43. You could create, like for instance, in a documents directory or whatever, you create like an assets directory where you can name it 43 whatever, or put it in a folder of 43, right? Where it's not necessarily in core data. The core data will support allowing you to put large binary objects in them, blobs, for lack of a better term. That's kind of the term. You can do that, but like your database will get really, really big, depending on, like a gig video. If you got a gig video, not that you're going to do that, but it's possible. You don't want to add a gig video to your core data. Holy smokes, that's like, that's a little crazy. So for something like that, I would say, look, make that as an offline thing. Can you install some security? Are there PII issues? Yeah, maybe not. If it's a product video, no one's going to care. There's nothing private about that. But that's what the reference by ID is. So whenever you've got all of your objects with IDs, you can just match them to assets. That's a particular strategy. So core data is basically waiting for the service manager networking, however you set that up. Your background networking guru basically talks to core data and says, okay, give me all the unsynced stuff, right? Or if it's doing a sync and goes, okay, so I did my unsynced stuff. Now that you've gotten all of that, why don't you give me an update on all the things that you've got that I don't necessarily have? I found typically that most users are not bouncing back and forth between their mobile apps and web a lot. That doesn't happen a lot. Usually you are very safe in doing all of your unsynced data first. And then you can verify things as they're coming back, as you're doing the sync. So my recommendation, my experience is, get the things that you've done to the server first. That may not be true based upon what your app is doing and how it's doing things with the database. Hard to know what that is. That's up to you to determine which one to do. And then the service manager is the only thing that is talking to the server database or wanting on the server database. So this is basically isolating the UI. UI never depends on any networking calls whatsoever. That's the philosophy behind it. And that's the presentation. Are there any questions?
Did you convince everyone to do it this way?
I haven't talked to them yet. I know it's a little complicated, to say the least. But anyway, this is one approach to do it if you want to do core data as a repository. So that's really the choice is what's best for your app and what's best for the persistence you're trying to do. Do you want to persist requests, or do you want to persist an offline repository? That's the question, and those are two very, very different things, and they will affect what your core data design is going to be.
Would you follow this similar data flow if you were to have your app be on the charger at like 5 a.m. and do an update?
Sure, yeah. I mean, as an app developer, I don't have to care because iOS is, your phone is keeping the heuristics of it. Like whenever you're doing your activity on your apps, it is basically watching your habits. It's not quite as big brother as Google, right? Because they're not doing anything to it. But it's basically there as a convenience. So like for your app, you'd have to sign up for it. So you can sign up to say, this is the schedule I want to follow for background processing. Or you say, you know what, do it based upon what the user is doing. And you determine what that is. So really, as a developer, I don't know when the updates are happening. I kind of don't care because everyone's different. But I'm a big fan of, and haven't had a chance to use, but I'm a big fan of the idea of doing the background processing, especially for this kind of app approach that is wanting to be really powerful in offline mode and search. So that's really the question is, do you want to go offline? Do you want to have massive searching? Do you want some isolation from design views twisting your database design? The thing I didn't put into these slides, now that I think about it, is lightweight migration. How many have had to do core data migration, let alone core data? Were you able to do lightweight migration? Or did you have to do an ugly manual migration?
Both.
Both.
In every combination.
Okay. So please share with the group how ugly can potentially a manual migration be?
Well, instead of the lightweight ones, at least for me, it kind of was like, you're kind of just trusting it to do the thing.
Yeah,
It's like this black box of scariness.
it actually does work.
Yeah, no, it works. I'm just saying, yeah.
It feels like
I don't like
magic.
black boxes that are too much.
Does magic make you feel uncomfortable?
Sometimes.
Yeah, lightweight migration is really, really good. And that's like its own topic. I'll be happy to talk offline if somebody wants to. Doing it manually, your chances, if you're doing request-based where your views are driving what your data design is, the chances, that's usually how you almost can guarantee at some point one day you might run into the manual migration. That's, in my experience, like other databases where I've like looked at stuff where things aren't working, that is really prevalent. Why? Okay, any other questions? Thanks for your time, guys.